Hello and welcome to In Depth. I'm Ashwarya with you. Today we celebrate the 131st birth anniversary of one of the world's greatest physicists, Chandrasekhar Venkata Raman. Raman was the first Asian to win the Nobel Prize for Physics in 1930. He was also conferred the Bharat Ratna. In 1928, CV Raman wrote himself into history books by discovering the evidence of the quantum nature of light that came to be known as the Raman Effect. The day of the discovery, 28th of February, has since then been celebrated as the National Science Day in India. Over the next half an hour, we will take a look at the great scientist's life and times, his enduring impact on science and the development of scientific temper in India, and of course, his path-breaking discovery. Over 1,598 students on Wednesday paid tribute to Dr. CV Raman a day before his birth anniversary by creating a Guinness World Record for the largest astrophysics lesson and the assembly of spectroscopes in Kolkata. The feat was achieved on the first day of the India International Science Festival at the Science City. Astronomers used spectroscopes to know details like temperature and chemical composition of celestial bodies that are light years away from Earth. The invention is based on the discovery of Sir CV Raman. A small model of advanced spectroscope can be made by using a cardboard box with a very narrow window for channeling light into the device. On behalf of the Guinness Book of World Records, a memento was given to the Inter-University Center for Astrophysics and Astronomy, organizers of the session, at the end of the program. One of the most prominent scientists India has ever produced, Sir Chandrasekhar Venkata Raman, who received the Nobel Prize for Physics in 1930, was born on 7th of November 1888. On the noted physicist's 131st birth anniversary, here is a look at a few interesting facts about the Nobel laureate.
I am the master of my failure. If I never fail, how will I ever learn? Whatever and how many ever his failures, people for all times to come will be grateful to Dr. Chandrasekhar Venkata Raman for his successful discovery of the Raman Effect. Nobel laureate, eminent physicist and Bharat Ratna, CV Raman's work contributed in many different ways to the growth of science in India. Not only a great teacher, he motivated and instilled scientific temper among students in India and the world. For his groundbreaking work of light scattering, CV Raman was awarded the Nobel Prize, the first Asian to win the prize for physics in 1930. CV Raman was born in Trichy, Tamil Nadu on November 7, 1888. His father, Chandrasekharan Ramanathan Iyer, was a lecturer. At an early age, Raman moved to Visakhapatnam where he studied high school. He passed matriculation at the age 11 and the FA examination with scholarship when he was just 13 years. From a very young age, Raman was interested in science, reading books that his father had used as a student. In 1902, Raman joined Presidency College in Madras, where his father was a lecturer in mathematics and physics. In 1904, he obtained a BA from the University of Madras, where he stood first and won the gold medal in physics. In 1907, he completed his MSc at the University of Madras with the highest distinction.
CV Raman, he was born in Tiruchirappalli, now known as Trichy, in the state of Tamil Nadu. Then he had his early education there, and then he came to Presidency College, Madras. And he was a very good student, and he studied physics and mathematics, and also he was very strong in English. And of course he got gold medal and scholarship because of his exceptional ability as a student.
Raman also worked on the acoustics of musical instruments and was the first to investigate the harmonic nature of Indian drums. For nearly a decade from 1908 to 1918, Raman investigated vibrations of strings and other instruments like drums and mridanga. In 1917, Raman resigned from government service after his path-breaking research earned him the post of full-time Palit Professor of Physics at the University of Calcutta. The post marked a decisive professional shift into the scientific world. In 1926, Raman established the Indian Journal of Physics as its first editor. In fact, it was the second volume of the journal that published the discovery of the Raman Effect in the article A New Radiation. On 28 February 1928, he led an experiment with K.S. Krishnan on the scattering of light that came to be known as Raman Effect. Since then, 28th February, the day of the discovery, has been celebrated as National Science Day in India. In 1929, Dr. Ernest Rutherford, the man who discovered the nucleus and the proton, referred to Raman's spectroscopy in his presidential address to the Royal Society. Raman received a knighthood from them as well. In 1930, he was awarded Nobel Prize for Physics for his work on the scattering of light and for the discovery of the Raman effect. In 1932, Raman, along with Suri Bhagavantam, discovered the quantum photon spin.
He was very much interested in Veena and sitar and various types of drum instruments, mridangam. So he wanted to know the science of sound, physics in particular, and he used to explore those things, stringed instruments, percussion instruments, and so on and so forth.
CV Raman was also the paternal uncle of Subramanian Chandrasekhar, who won the Nobel Prize in Physics in 1983 for his discovery of the Chandrasekhar limit in 1931. Raman was awarded a Bharat Ratna in 1954. Bureau Report, Rajya Sabha TV.
And in In-Depth, we'll take a very short break. More on the life and times of Sir CV Raman on the other side. Stay tuned. A glass of water has no color, but a deep blue sea with the same water has a brilliant blue tinge. It is this curiosity that led to the discovery of scattering of light, which we now know as the Raman Effect. Our next report explains in simple terms what exactly this physics phenomenon actually is.
In 1921, Sir CV Raman began seeking answers to some primary questions that rise in the presence of nature. On his way back from his first visit to Europe via sea, Sir Raman was fascinated by the deep blue color of the Mediterranean. He was aware of Lord Rayleigh's explanation that the color of the sea was due to the reflection of the blue sky. But the question remained, what was it that deflected the light and made its passage visible? In his quest, Sir Raman proceeded to demonstrate Rayleigh's explanation to be false with a polarizing nickel quartz prism that he always carried in his pocket. He quenched the theory of surface reflection of the sky on the sea and noted that the blue color of the sea was unattenuated. During this voyage, Raman sent 2 papers to the journal Nature positing that the color of the sea was due to light scattering by the water molecules, a phenomenon he called molecular diffraction. Thus began Sir Raman's new research obsession, the molecular basis of light scattering.
When light passes through a medium, there is a deflection, and this is due to certain kind of light scattering. And the origin of it and why this happened and depends on the medium. If it is water, it will be one kind. If it is diamond, it will be another kind. If it is alcohol, it will be another kind. So it could be useful tool for determination of the structure of the molecule which was contained in that medium.
Raman and his students observed the frequency shift of scattered light. They knew the phenomena was not really scattering, since that type of scattering did not produce a frequency shift. When light encounters molecules in the air, the predominant mode of scattering is elastic scattering, also known as Rayleigh scattering. However, Raman and his team needed to exclude the possibility that minute traces of fluorescence were causing the shift. To do this, they purified the liquids multiple times, and when the phenomenon remained, they concluded that it was not due to fluorescence. By 1925, Raman had observed the frequency shifted scattered light in more than 50 liquids, and by 1927 he had noticed that the scattered light was polarized. He described the phenomenon, which he called modified scattering, in a paper in Nature. Later, it became known as the Raman Effect. What Raman and his students also showed was that the phenomenon held for solids, liquids and gases. The universal nature of the Raman effect has made it indispensable for a vast array of fields.
We all know atoms have a nucleus and an electron is going around it. So when a photon comes near an electron, it will be either absorbed or reflected. That's what will happen essentially. So all the reflection is because of the photon coming and hitting an electron and going back. Okay, a photon comes, hits an electron and goes back. That's essentially what's happening, right? Now imagine you are holding a cricket bat and you are just swinging the cricket bat back and forth. Okay, and somebody is throwing a ball. When the ball is coming and hitting a bat, if your bat is going backwards, when the ball is reflected, the reflected ball will have less speed compared to the incoming because your bat is going back. But assume now the other case. Suppose when the bat is going forward, the ball comes and hits. The ball will gain more momentum and will be going faster, right? And when it is exactly in this edge, or when it is exactly in this edge, if the ball hits, it will go with the same speed, whatever speed in which it came, right? So there are three ways reflection can happen. Same energy, little bit more energy, little bit less energy. Raman discovered that this energy difference, right, little bit more, little bit less compared to its normal, is characteristic of every molecule. You get my point? So if you have a molecule, let's say water, the water's upper reflection, upper energy or lower energy. So if I send a particular wavelength, I'll get three wavelengths back. Most of them will be the same wavelength. Little bit will be slightly higher, little bit will be slightly smaller. If I measure the difference, I'll know what that material is reflecting.
Sir Raman was awarded the 1930 Nobel Prize for Physics for discovering the effect, which has been widely used in sensing and identifying materials from drugs and pathogens to nanomaterials. His research and experiment has also played a role in fundamental discovery, including developing ideas in atomic physics. Bureau Report, Rajya Sabha TV.
And more than 90 years after its discovery, Raman Effect continues to play an important role in latest scientific discoveries. In our next report, to take a look at how Raman Effect impacts our everyday life.
In simple terms, the Raman effect is the deflection in light when it passes through a transparent material. The changes in the wavelength is now called Raman scattering or Raman effect. Nearly a century later, Raman's discovery continues to be at the forefront of new applications. In 2013, a team of scientists from the Harvard University and the University of Michigan reported a new weapon in the battle against brain cancer. An imaging technology that makes brain surgery dramatically more accurate by allowing surgeons to differentiate between brain tissue and tumors at a microscopic level. The scientists used the stimulated Raman scattering or SRS microscopy on mice. SRS works by shining non-invasive lasers into tissue. The spectrum made by the weak signals help in building images of the cellular makeup of the tissue. It would show the tumor in blue colors and healthy cells in green, which allows surgeons to excise the tumor accurately.
I think it is used in medicine, it is used in surgery, detection of cancer cells as opposed to healthy cells, even in satellite sensing. So its applications are very widespread.
Raman spectroscopy is used in many varied fields where non-destructive, microscopic, chemical analysis and imaging is required. It shows the chemical composition and structure of any sample, be it solid, liquid, gas, gel, slurry or powder, helping to identify substances in fine detail. Most commonly, we see the uses of Raman spectroscopy in airports and metro railway stations, where Raman spectroscopy can identify dangerous substances like improvised explosive devices. Security experts call Raman scanners the best devices to detect explosives carried by terrorists. Raman scanners are used by narcotic squads and airports to detect drugs too. Safety inspectors are using Raman scanners to detect hazardous chemicals and gases. Police forces are using them for forensic work. Researchers have incorporated the Raman effect on silicon. Because of its crystalline structure, the Raman effect is 10,000 times stronger in silicon than glass.
Many spacecrafts made by any other countries carry Raman spectroscopy. Remote sensing, Raman spectroscopy is used. When you want to find whether a material is adulterated or not, you are using Raman spectroscopy. So Raman spectroscopy has become an essential instrument today. So 50 years, many years have passed by the time Raman discovered this effect and got his Nobel Prize. But even today, the technology that came out of his research is still a very important tool for today's research development and work.
The most common applications of Raman spectroscopy include quality control in pharmaceutical industry and in medical diagnostics as well. Raman spectroscopy is a valuable tool to analyze highly complex materials like biological organisms and human tissue. It is used in geology and mineralogy for mineral identification and behavior. Raman spectroscopy is fast and non-invasive. That makes it a perfect technique when time is limited. Identifying the chemical composition of a substance typically requires chemical and physical tests that take time, but Raman scanning can take just 20 seconds. The spectrum of Raman scattering contains so much information about a sample's structure and composition, it has been described as a characteristic fingerprint. Hundreds of papers are written each year as physicists continue to tweak this powerful technique for new applications. Bureau Report, Rajya Sabha TV.
Known for his groundbreaking work in the field of light scattering, Chandrasekhar Venkata Raman is responsible for putting India on the global science map. The years of research that Raman put in are a shining example of the promise of laboratory work in science. Raman's relentless search for answers to some basic questions surrounding nature also gives a glimpse into how important the development of scientific temper is for a nation. Let's now take a look at the legacy that Sir CV Raman left behind for generations to come.
winner of the 1930 Physics Nobel had a clear vision for the country that India needed homegrown talent and a blueprint for scientific research. Not a believer in big laboratories and institutions with instruments imported from other countries, Sir Raman also abhorred the idea of sending students and researchers abroad for training. Sir Raman is famously quoted as having said, "My life has been an utter failure. I thought I would try to build true science in this country, but all we have is a legion of camp followers of the West." However, he wasn't one to shun Western science or scientists. Sir Raman was frequently in contact with renowned European scientists like Max Born and Erwin Schrödinger, inviting them to come and work in India. Max Born was appointed to the chair of physics in IISc, but he did not continue in the position due to differences. Sir Raman was a big believer in the building of a scientific temperament. He wanted to promote science and scientific temper by encouraging a true scientific spirit of inquiry and investigation, and he himself lived by that rule.
See, when the Nobel Prize was given to Raman, this was in 1930. India was a colony under British crown, right? So the tradition in a Nobel ceremony is that the flags of Nobel winners would be placed and the national anthem will be played and all people will rise. So when Raman was about to give his Nobel lecture, that is when you receive a prize, you have to give a speech. It's actually in a banquet, not actually during the award ceremony, but after the award there will be a banquet where people will be served food, etc., where you give a acceptance speech. In the acceptance speech, Raman talks about this. I am coming from a poor country which does not even have its own flag, right? So he was a nationalist to the core. Even before India became independent, in his institute, he instituted what is called as Gandhi lectures. Imagine during British time, in an institution, you are saying that I am going to have a Gandhi lecture. Okay, today it is possible, but imagine before India attained freedom. He was saying science should be used for India's development, India's upliftment. He was starting to do research on crystals. So for doing research on crystals, he needed different kinds of crystals. So he spent all his money on buying those crystals for doing research.
His inquiry into simple things like why the sky is blue or why water, itself a colorless liquid, seems blue at sea, ended up explaining what we now know as the Raman Effect. This discovery gave new directions to the study of light and also won him the 1930 Nobel Prize in Physics. He was pursuant in his research into the phenomenon, and it opened up a world of applications from airport scanners to helping surgeons operate a brain tumor. Sir Raman's clarity of thought that he did not want governmental interference in the development of science led him to establish the Raman Research Institute. It represented everything he had envisioned in a research body, free of fetters and ready to soar to great scientific heights. Sir Raman may have been a physicist, but he also had vast knowledge of the arts, having earned a master's degree in arts at a time when studying physics meant travelling abroad. Thus, the man who won the Nobel Prize for his work on the scattering of light also brought together science and art, spending years studying the acoustics of Indian classical percussion instruments like the mridangam and tabla, and doing some seminal work in the area. Raman set out to understand the physics behind these instruments through a series of experiments in 1919, showing that an interest in one subject could never be a barrier in the study of another. Bureau Report, Rajya Sabha TV.
And that's it from us today in depth. We'll be back same time tomorrow with a focus on another key subject. You can also watch our program online on YouTube, the link for which is flashing on your TV screens. Suggestions and feedback about the program are also welcome. Thank you so much for your time. Bye-bye.